Hey, welcome back to Mr. PL's with Precal. This is Unit 1, Topic 4, Lesson number 4. And we're going to be talking about complex fractions. So we're starting off this question with just regular fractions, no variables in this case. So we have 4 divided by, and then these two fractions. Now remember, you can only add or subtract fractions when you have a common denominator. So we have 3/4 minus, now if we make this one out of 4, so times 2 makes it 6/4. So then I can simplify that. So 3/4 minus 6/4 makes negative 3/4. Now I have division. Remember division, you can leave, change. So it's really 4 divided by becomes multiplied. So leave the 4 alone, change division to multiplication, and then change the denominator to its reciprocal, because it's like dividing by 2 is the same as multiplying by a half. It's the same as multiplying by its reciprocal. So that would be 4 over negative 3. Then you can simplify this. 4 times 4 is 16. 1 times negative 3 is negative 3, which that can then be simplified to a mixed number. 3 goes into 16. Would that be 5 times with 1 left over? Be your answer in simplest form. Okay, same thing over here. So we have 2 divided by 3/2. Move myself for a second. 3/2 minus, okay, actually no, I need to do 6. So let me erase that. I need to use the common denominator, which is the same way we're going to be doing in this lesson. So times 3 makes 9/6 minus, also 6 times 2 would be 8/6. So that's going to be 2 divided by 9/6 minus 8/6 would be 1/6. Now I can easily change. 2 times 6 over 1. And that equals 12. Same thing goes here. Only thing, we have a variable this time. So this time we have 3 over x plus 1 over x. Well, anytime you add, you have a common denominator. So 3 plus 1 is 4 over x. So now we have x times x over 4. And then that's going to give us x squared over 4, and that's as simplified as we can possibly make it. All right, so kind of the things I just went over actually are very much the same as what we're going to be doing in this lesson. I'm going to show 2 different ways of thought to answer this kind of question right here. This is our complex fraction, which involves polynomials. You can think of it as this fraction divided by this fraction, kind of like it was in the warm-up. Once again, 2 schools of thought. So step 1 would be factor out. Well, these don't need to be factored here because they're already in factored form. Like this one's in standard form, I would change it to factored form. And then you're going to find common factors. Now, the easiest way of doing this question, one school of thought, is do x plus 5 and x plus 5 are the same. So I'm going to cross out this x plus 5 and one of the x plus 5s on the top fraction. So they're both in the denominator. X plus 4 is in both in the numerator. So I can cross this one off and cross off this squared. That's kind of like crossing off one of the x plus 4s in the top. So you're left with x plus 4 over x plus 5. And that is going to be the answer. Now, that's going to be incredibly a lot easier and less work than the second school of thought, which I'm going to prove as to why that works. So just like before, we're going to have x plus 4 squared over x plus 5 squared, and leave this fraction alone, change division to multiplication, just like we did on the warm-up, and change this to the reciprocal. Now, from here, you can see that we can reduce diagonally. We can say x plus 5 in this, and x plus 4 in this, and then you're left with x plus 4 of x plus 5 again. So once again, we're getting the exact same answer, just 2 ways of doing the same thing. So like I said before, the directions would be to factor completely. So this up here would be x, what is that, minus 5 times x minus 1. Over x minus 2 times x plus 2. So that can be factored as well. And then that all gets divided by x minus 5 times x plus 5. And that gets to, let's see, and then this is factorable. This can be changed into x minus 3 times x minus 2. Okay, so in the denominator, they're in both denominators. If they're in both the numerators or both of the denominators, they can be reduced. So this is also in the numerator, this is also in the numerator. So now I'm left with x minus 1 over x plus 2 times being multiplied. So leave this alone, change this to multiplication, change the bottom to its reciprocal, which would be x minus 3 times x plus 5. So then I could multiply. So I'm going to be left with x minus 1 times x minus 3 over x plus 2 times x plus 5. Now, I could multiply those and get it into standard form. That'd be the exact same thing, but this is already in factor form, so I'm going to leave it just the way it is. Okay, moving on to the next one. I'm going to just do a couple of these due to the time constraints. These are practice of what we had just done, but I also want to get into some new types of questions on the next slide. So the top can be factored because both of these terms can both be divided by 3. You're left with x minus 3. And on the bottom, you have two factors. This would be x minus 6 times x minus 1. All that fraction being divided by, you can factor out the GCF here, so that'd be 4 times x minus 3 divided by x plus 6 and x minus 6. Okay, so the x minus 6s can be, they are both on the denominators, and the x minus 3s are on the numerators, so those quite easily get crossed out. So we're left with 3 over x minus 1, which is what was left on top, being multiplied by what's left on bottom, but it's the reciprocal, so it's x plus 6 over 4. All right, so that's going to leave us with an answer of 3 times x plus 6 over 4 times x minus 1. And there's our answer. Okay. So like I said, I want to get to the next slide. So in this case, we have something slightly different here. We have, kind of like we had in the warm-up, we have these whole numbers right here. And in order to add and subtract things, remember we said in the warm-up that you have to have common denominators. So we're going to need to find that common denominator first and simplify this first and simplify this before we can do any of the division. So now this is like over 1, and the LCM, the lowest common multiple of 3 and 1 would be 3, or least common denominator in this case. So I'm going to multiply this by 3/3. Now keep in mind that's not really changing anything because that's like multiplying it by 1. So that's going to turn this into x over 3 plus 15 over 3. And then all of that, do the exact same thing on the bottom. So this is really over 1. So I'm going to multiply this fraction by x over x. And that's going to give me 7 over x plus, 7x over x plus 6 over x. Now I can simplify this again by adding things that are together. So x plus 15 over 3 over 7x plus 6 over x. All right, so now from here, I don't see any common factors on top and bottom, so I'm going to change this to leave, change, change. So x plus 15 over 3 times x over 7x plus 6. All right, so that becomes x times x plus 15 over 3 times 7x plus 6. Now, I could probably distribute that and distribute this, and if I did that, that's going to be x squared plus 15x over 21x plus 18, and that's about as simplified as I'm going to be able to get it. So like I said, so instead of leaving it as factor form, I changed it back into standard form. All right, so a lot of steps, but it is pretty much the exact same process as it was for all the prior questions. I'm going to erase all that so I can do this next question. All right, so once again, no common denominator here. So we're going to multiply this side by 3 over 3 and multiply this side by x minus 2. So like we've talked about before, the least common denominator, you can always just take the two denominators and multiply them by each other. So that's going to leave you with x minus 2 over 3 times x minus 2 minus 5 times 3 is 15 over 3 times x minus 2. So that's the bottom. And then the top is still 15 over x minus 2. Now I can simplify because both of these are going to get crossed out. So I'm left, I'm sorry, not crossed out, sorry. Let me take that back. So it's going to be this minus this. So it's x minus 2 minus 15 on top over 3 times x minus 2. And on top, it's still the 15 over x minus 2. Okay, so the x minus 2 gets crossed out. So we're left with this over 3. So that's going to be 15 over 1, which is left on top, times, and then this gets reciprocal. So 3 over x minus 2 minus 15, like this. And okay, so 15 times 3 is 45 over x minus 2 minus 15. Anything times 1 is itself. And that's as far as I'm going to take it in this case. All right. Yeah. So we've got a couple of examples of that. So then it comes into the U-try and doing the exact same steps. I'm going to stop it right there, just like I have with other videos, give you a chance to do these problems on your own. Thanks again for watching, and please look forward to future videos. Have a great day.